Hello. Hopefully you all enjoyed your long weekend. The weather looks like it was supposed to be beautiful. And we are now entering the second to last week of official online class. For CAP week, we are not going to do any sort of major project or anything like that. I'm just going to give students who aren't quite as caught up the time to catch up and finish any assignments that they haven't gotten in for the class. This week, let me show you what we are up to. You guys are going to be working on the 15.2 Taco Tongue or Evil Eyebrow lesson on the website. So if you click on the part 4, it is the 15.2 assignment right here. The very first thing that hopefully you do, I'm going to explain it in the video, but if you want to go back and read it, you can, is we're going to be talking about which or do we mean when we talk about probability. So if I say the probability that someone owns a cat or a dog, you might say, well, there are a few different options for what that or can mean. So I found this post, it does a really good job of using a funny example to explain which or we mean. So Applebee's versus Starbucks. So down here they explain, if you go to Applebee's and you ask to order a bacon, you are asked maybe whether you want French fries or onion rings. So that's one type of or. When you have that type of or, hold on. That type of or means you get one or the other, but not both unless you want to pay a little bit of a fee. Now you go to Starbucks and you order a coffee and you get the question, would you like cream or sugar? So at Starbucks, this or means, do you want cream? Do you want sugar? Or do you want both cream and sugar? This is the kind of or that we're going to be using for probability. And so when it asks for the probability of, say, the cat, someone owning a cat, or the probability of someone owning a dog, it means they could own a cat, they could own a dog, or they could own both. So we want all of those options in there. We are going to work on this thing. This is what you're going to turn in for the week. And I'm going to do an example with some slightly different numbers on it so you can see how it works and get the general gist of this. So with this, we did this in my AP Stats class earlier in the year, and we figured out whether or not they could roll their tongues, taco tongue, or if they could raise their eyebrow, aka evil eyebrow. And then we figured out like who could do both, who could do none. And in your example, you're going to use all 24 of my AP Stat students, and I broke down the numbers here. So you can use the numbers to fill in the table, fill in the Venn diagram, and then calculate some probabilities. A side note, if you are doing this and you're typing it up, this image, you can double click on it and you can edit the text boxes here and fill in the numbers instead of having to draw it out. So let me hop over to the iPad. And you can see I've got a few different example numbers on here. So on yours, there are 24 students. On mine, there are only 13 students. And then I've got different numbers here, but I'll show you how you can use those to do basically the same things, but you're just going to have to adapt to the numbers you have. All right, so in one section of my classes, there were 13 students that day. There were 8 students total who could not raise their eyebrows. There were 2 people who could raise their eyebrows, but they couldn't roll their tongue. And then 10 out of the 13 students could roll their tongue. So we're going to use that information to fill in this thing here. It's called a two-way table. The other name that I've seen is a contingency table. And then this guy right here, I bet you have seen these a lot. These are called Venn diagrams. So both of these diagrams are really helpful when it comes to probabilities like this. It kind of lays everything out very clearly, and you can calculate probabilities a whole lot easier than if you didn't have a picture. So on the two-way table, in the very last column and the very last row, we've got the totals. So what we're going to do there is put in definitely the total number of students I have. So down in total, I know I have 13 total students. And then the ends right here are going to represent the total amount of students that could raise their eyebrow. And then if you remember the notation that we worked on last week, this little C means can't do it. It stands for complement. So those are going to represent the total number of students that can't do these things. And then on the inside boxes, it's going to represent the students who were calculating the probabilities for those two things at once. So when I look at that first bullet point, there were 8 students total who could not raise their eyebrows. So I'm going to look at the row that involves students who could not raise their eyebrows. That's right here. And figure out which one of those 3 boxes that 8 is going to go in. So in this first box here, this would represent students who could not raise their eyebrows, but who could roll their tongues. I don't know anything about whether or not they can roll their tongues, so it's not going to go there. Same thing with that second box. I know that these students would not be able to raise their eyebrows, but also can't raise or can't roll their tongues. So again, I don't really know what those 8 students can do as far as their tongues are concerned. So my only option left is to put it in this total row right here. So I know that there are 8 students total who could not raise their eyebrows. All right, next bullet point. There were 2 people who could raise their eyebrow. So I'm going to be working in this row right here, but they couldn't roll their tongue. So 2 students right there. And then the last one, 10 out of the 13 students could roll their tongue. So I'm going to look in the roll the tongue column. And again, I don't know anything about what they can do with their eyebrows, so that's going to make me put that number down here. Now you may be wondering, like, how do I fill in the rest of these things? This part's kind of fun. It's kind of like a little puzzle. You know that these 2 numbers have to add up to 13. These 2 numbers have to add up to 13. And then the same thing is going to apply for the row totals and the column totals. So you can just use a little creativity to figure out what goes there. So the number that would have to go in for can't curl their tongue would have to be 3, because 10 plus 3 would make 13. And then I can see here, 1 would have to go there because 2 plus 1 would have to make 3. And then we've got 8, 1, which would make this box 7. 10 and 7, this guy would have to be 3, and then 3 and 2 would have to make 5. So that's one way of showing the probabilities. Another way is to use Venn diagrams. And for this, we're going to take some of the same information and put it in a Venn diagram. Sometimes this can be a little bit trickier to figure out, but sometimes it's a little bit more useful. So in this entire circle, in this red circle, are all of the people who can raise their eyebrows. So I know all of those people would have to be 5 total. And that number is there just kind of temporarily until I figure out what portion goes in the middle, because I know some of those 5 people can also roll their tongues. So when I look on my Venn diagram or on my two-way table, I'm kind of looking at this row right here. I know that 5 can raise their eyebrows, but I also know that 3 of them can roll their tongues. So 3 of them can do both. So 3 is going to go right here. I know that the whole circle has to total 5, so that means that there are 2 people in the just red section, which makes sense. So this 3 corresponds with this 3 right here. This 2 corresponds with the people who can raise their eyebrow but can't roll their tongue. So that's that right there. All right, next we've got people who can roll their tongues, and I know that there are 10 people total. And I know that 3 of them are already accounted for in that inner circle. So that means that there has to be 7 people that can roll their tongues but can't raise their eyebrows. So now if we look at that, that 7 is coming from here. We've already got the 3 covered. And then we've got this like outer box here. This represents the people that can't do either of them. So I've got 1 number left. That's going to go right there. If I add them all up, so 2 plus 3 plus 7 plus 1, I should get my total of 13, which I do. Hooray. Oops. All right, so now let's have a look at how to calculate some of these probabilities. And I'm not going to do all of them because I think you're going to be able to figure them out for yourself after a little bit. So the very first one, the probability that someone can roll their tongue. For this one, we're going to look at the total number of people that there are. So out of our 13 students, how many could roll their tongue? And that number here, I can see that there were 10 of them. It's not asking me for anything to do with their eyebrows. Let's do probability that they can roll their tongue and raise their eyebrows. So roll their tongue. I'm going to be looking in this guy right here. And then raise their eyebrows is this one right here. So it looks like 3 people can do both. So, oops, 3 out of the 13. If you wanted to use the Venn diagram to do these things, you can do that too. So for the probability that someone could roll their tongue, I would look at everyone in this circle. So I don't care if they, what they can do with their eyebrows. I just want to know that they can roll their tongue. So I've got 10 over there and then my 13 total. And then if I wanted to do number 5, they can roll their tongue and they can raise their eyebrow. That would represent that section in the middle of people that can do both. So the 3 out of the 13. For the other ones, let's look at one of the or ones. So let's look at number 10, the probability that someone can roll their tongue or they can raise their eyebrow. So the probability, let's look at the Venn diagram for this one. The probability that someone can roll their tongue would be this group. The probability that someone could raise their eyebrow would be this group. So if I add up all of those people, 7 plus 3 plus 2, I get 12 people total. Something kind of interesting happens though if you tried to do this a different way. If I said, well, I know back from number 1, 10 out of 13 people can roll their tongue. And I know that 5 out of the 13 people can raise their eyebrow. So if I add those up, remember when you add fractions, just add the tops, don't add the bottoms. I get 15 out of 13. And hopefully that you can see like something is happening that's not right. I can't have over 100% of the people be able to do both of those things because first of all, I know that that's not true. I've got one person that can't do either of them. Second, how do you have a percentage over 100%? And hopefully what you're seeing is when I added those probabilities, first I said, okay, 10 out of 13, that's this circle here. 5 out of 13 is this circle here. And the problem that I'm encountering is that I'm adding these 3 people twice. So if I have events that overlap like these do, and I'm adding their probabilities like this, I've got to make sure that I go back and I subtract off the 3 out of 13 that overlap those things. So I end up with my 12 out of 13. All right, hopefully that's enough examples that you can get through the other few problems. Down below, you're going to have a little bit of review of what mutually exclusive means or not mutually exclusive. Um, Number 13 asks you the difference between how you might calculate these and how you might calculate these. A hint is it has something to do with being mutually exclusive. So remember, mutually exclusive means two things can't happen at once. So for example, in this, I can't be both a person who can roll my tongue and can't roll my tongue at the same time. So those two events would be mutually exclusive. And you can go back and kind of look at these probabilities that you're calculating, and it's going to be for 11 and 12, you're going to be looking for probabilities with two things happening at once. And if they can't happen at the same time, those two things are mutually exclusive. And then this little guy, remember that means can't. So find things that can't be mutually exclusive or don't have to be mutually exclusive. So for the big ideas, for number one, the general addition rule says if I'm calculating the probability of event A, let's say rolling my tongue, or event B, if they are mutually exclusive, then I can just say, well, it's the same as the probability of A plus the probability of B. If they're not, then I've got to worry about that problem with the overlap that you saw in question number 10. So what I would have to do here is say, well, it's the probability of A plus the probability of B, but I've got to subtract that extra overlap that I've added in twice. So I'd have to subtract off the probability of A and B. So two-way tables or Venn diagrams. So it's always good to make a graph, or sorry, always good to make some sort of a picture of your probabilities. Venn diagrams can look a little bit different sometimes. So sometimes you might have events that are mutually exclusive and will never overlap. Sometimes you might have events like we saw with the one that we just did, where you have events that do overlap. So Venn diagrams can be helpful. Other times, two-way tables can be, I don't know if more helpful, equally helpful, or user preference. A, sorry, not A. B, not B. And then one thing you always want to make sure to put in are the totals. And then this box down at the bottom gets reserved for the total in your sample. There is a fun little Venn diagram that you can check out on here if you want, see if you agree with it or not. And then down below are some of the check your understandings that you can do to turn in. There are a lot of them. There's some extra ones if you want more practice. So the first page I want everyone to do. It's very similar to what we just did. And then down below, there is some extra practice that you can do if you want. Additionally, if you want even more extra practice, you can go over to Delta Math and use this code 427434, and that's going to enroll you in my class. Make sure you pick the probability and statistics one, not the AP stats one. And then there's an assignment 15.2 general addition rule homework that you can do. And what's nice about Delta Math is um, you put in your answer and then it will give you feedback instantly about whether or not you got it right. So you can do a bunch of practice with Venn diagrams and two-way tables if you are feeling up for it. All right, I think that does it. Bye.